All right, so for this one, SQL injection, I think it would be good to start with the project I wrote because the Burp Security Academy does not explain what SQL is, and a lot of people don't know. So I got here, this is ED 103 here in my standard projects. So here's a server. First you reset it to make sure the database is back to its default condition. And SQL is the language used to control databases. And here you have a field where you can execute commands that are available to the SQL, to the database administrator. So the administrator could execute show databases, and then you'll see this thing has two databases, one called information schema and one called widgets. And then you could show tables. Each database contains tables, and each table contains fields. So here are the tables in the default database called widgets, called employees. So there's a table called employees, and you could get all the data from employees with select star from employees. And now you get whatever's in that table. In this case, it's ID number, name, and social security number for each of the 3 employees. And this is why you would not let an end user use this kind of field. Only the administrator should be allowed to do this, access all the data, which might be private. Now, here I selected everything from employees. You could also ask for just one field, like just the ID. Then you get just the IDs. Or you could ask for 2 fields, like ID and SSN. So you can get anything you want as long as you know the name of the field and the name of the table and the name of the database. And those things can be found because there's this thing called information schema is automatically generated by the software, and it always has the same name. So you can get a list of all the tables. With this one, select table name from information schema tables, and now you'll get all the tables in all the databases. Now the ones in capital letters are automatically generated by the software and usually not very interesting. The one at the end in lowercase letters is the one that actually contains personal data of these employees, and that's a higher value target. So those are all the tables, and you can similarly get all the column names from that information schema table with this one. And so again, you get a lot of automatically generated column names that are capital letters, and at the end, the lowercase that are in the employees table. So by using the known name of the information schema table, you can get the information schema database and the known names of the tables inside there with names like tables and columns. You can find out all the information you need to get the other data if you have the ability to execute these kind of commands. Now, there's a couple flags you find just by using those SQL commands up here. But now we're going to do SQL injection. This is just SQL, structured query language operating as written. Injection is where you execute SQL commands that were not intended to be executed except by the administrator. You would not give your customers this ability to enter a form like this to enter a query, but you do give them a form like this where you can search for something by name. So all you're supposed to be able to do is put a name here and search for it, and then you can find whether Bill Gates is in the table. But if you put in a name with an apostrophe, like Tip O'Neill, then you get an error message. And this is a syntax error. This should not be possible. No name should cause the program to crash. All it should be is either finds it or it doesn't find it. But the problem here is it is executing this command on the server. And I put the name in here. And the fact is the name is not understood as a name by the server. It starts with an apostrophe, and it thinks the apostrophe ends the name, so it thinks the name is this here, Tip O. And this apostrophe that entered by the customer is confused with this apostrophe entered by the administrator, and so this Neil is now expected to be a SQL command. So we have command injection. We can enter something in data that is misunderstood by the server as a command. Now this is not a valid command, so we get an error message, but that's command injection. So we can put in a valid query string like this. Now, the way the server interprets this is select fields where the name equals Sam or 1 equals 1. This is a compound condition. The first condition is always false. The second condition is always true. So this combination is always true, and you get all the names. And the pound at the end is a comment signal, causing it to ignore the extra apostrophe that would otherwise cause a syntax error. All right. But this is the one that really matters. This is where you use union select. And now, select name from employees where name equals Sam. This results in 0 answers. There is nobody named Sam. But then add select 1. And select 1 just selects the literal word 1. So now I was able to run a select query of my choice. The result of this injection is I have turned this input field into that input field. I can now enter any select query I want. So if I want to know the names of the tables in the database, I can take this one and put it in here. And I hit the wrong key. I got to copy it up here. Here's the names of the tables. And I want to paste it in here for that select query. All right. And now I get all the tables. The only rule, though, is I see employees and passwords are the names of tables. All right. The only rule is you can't have a different number of columns in the two fields. So if I select just numbers here, I did where I select 1, and that worked. But if I tried to select 2 columns, like 1, 2, I would get this error message showing the 2 select statements have a different number of columns. So when you're using this union select injection attack, the first thing you have to do is determine how many columns there are, and then you can ask for any data you want, and it will be added to one of the columns that the administrator put there. So there are some challenges to solve there. Now, if you are doing this in a real penetration test, you don't normally do it manually like this. You use this tool called SQLmap. And if you have a Linux machine or a Kali machine, you can install SQLmap, or it may already be there on Kali. And then you can use SQL. Here's an old project of mine where I show you the steps. In SQLmap, if you just give it SQLmap -u and the URL, it will test it for vulnerability and determine if one of the parameters is vulnerable. Then this is how you find the databases with these command line switches, and then you find the tables, and you find the columns, and then you can dump the data. So those are the steps that this tool automates the process that we've been doing here manually. And this last part is very much like the blind command injection we just did. You can have blind SQL injection. So here you have another place where you can search for a name. If you search for Bill Gates, it finds Bill Gates. So it looks the same as the previous one. But if I search for X, it doesn't have any results because there's nobody named X. So it still looks the same. But if I do a SQL injection like this one, now this is the way the query looks. Select name from employees where name equals X, which is always false, or A equals A, which is always true. So this should give me all the records in the database, but all I get is it echoes back my injection. This thing never prints any data from the database. It looks for somebody, and if it finds them, it gives you not their name from the database, but the name from your query. So there's no condition under which I get any data from the database, but you can still get it by inference. Notice if this condition is true, I'll get an answer. If it's false, I won't get an answer. So you can now ask one true or false question. So for example, this A equals A is true, so I got an answer. If I make it B equals A, it's false, and I get no answer. So now I can still get data from the database. I just have to pump it out that way. So for example, if I want to know the length of the database name, I can run this. And if the length of the database is equal to 1, this condition will be true, and I'll get an answer. I don't get an answer, so the length of the database is not equal to 1. You would think it must therefore be greater than 1. So I can check to see if that is true. And that is true because I get an answer. So in this spirit, you can pump things out one by one. And so there's a variety of flags to find here. Now, if you wanted to get a alphabetical field or a character field, like a password, you have to use something like this. Union, select name from employees, where name equals Bill Gates, and I'm just going to get the name because I know what the name is, not the password. Substring of name 11 equals B. It's asking if the first letter of Bill Gates is B, and that, of course, is true, so I get an answer. The first letter of Bill Gates is not A, so if I put an A in here, I'll get no answer, but it is greater than A, because you can treat letters like numbers in SQL. They're just treated as their ASCII codes. So a capital B is greater than a capital A. So this condition is true. So you can use greater than and less than to narrow down things, and you can track down things. You can even find passwords here by zeroing in on them character by character that way. So you might want to try that stuff. That's introduction to how SQL works, how SQL injection works, and how the language SQL works.